Hello, welcome to our run through lecture 2. In the first video, we're going to be talking about something very interesting. We're going to be laying a foundation, right, for some of the very, very important concepts that you're supposed to know in this slide. Okay, so in this video, we'll be talking about chemical elements and compounds. I can do this. Let me do something which can help you understand already what this video is going to be like. We're going to be talking about chemicals, which are elements and compounds. So that's the first thing, okay? The heading is chemical elements and compounds, which we can say chemical elements and chemical compounds, okay? Or we can just say chemicals, which are elements and compounds. So let's start by going through the definition of what a chemical is, and then we focus on what it is that we want to know, okay? We're not going to focus much on the elements part of chemicals, but then we just have to know that they're included in the definition. So what is a chemical? Now that we've gone through some ways of separating things in chemistry, when we talk about a chemical, we will be talking about a substance which has properties that are distinct. We know that chemical properties are used to separate things. Okay, we use boiling point to separate things. We can have physical or chemical properties, right? Boiling point is a chemical property because it's something that we can use to differentiate between matter. We can use to differentiate between alcohol and water, right? So when we talk about a chemical, we'll be saying it is a substance that has its own properties, which we can then use to separate it from the rest of the things. So a chemical is any substance with a distinct set of properties, okay? And also a distinct composition. In other words, it has its own structure, okay? It can be either an element or a compound. So chemicals are either elements or compounds. In other words, in summary, we are just saying that all compounds are chemicals and all elements are chemicals. So that is what it is. All chemicals are either going to be elements or compounds. Okay? If you take chemicals, you can separate them into either elements or compounds. That is a chemical, something which will have a distinct set of properties. Now, here are some examples. We start with one, oxygen. What makes oxygen a chemical is that it is an element, okay? It is an element. Why is it an element? Because if you go into oxygen, you only see one type of atom in it. An element is something that is one type of atom. We know that from our lecture 1. So oxygen is an element. We go to water. Water is a chemical because it's a compound. What makes it a compound is that it has two different types of atoms in it, because a compound will have at least two different types of atoms in it. It has hydrogen atoms, it has oxygen atoms. So it's a compound, and that makes it a chemical as well. So chemicals are either compounds or elements. Now another one is sodium chloride, which is a chemical also because it's a compound. So these two are compounds, and that makes them chemicals. So we can call them chemical compounds. This is an element, and that makes it a compound because it is an element. So we can call it a chemical element. Chemicals are either compounds or elements. Now that we know about the definition, let's go ahead and look at what we actually want to focus on. Okay, we're not going to put attention to chemical elements, but we want to focus on chemical compounds and the ways that we have of separating them, because this is so important to what you are going to be learning as we go on in this lecture 2. So we are looking at chemical compounds only, not the elements part, but the compounds, because chemicals are either elements or compounds. We are looking at compounds, right? And we are looking at two ways that we have of separating compounds or of separating chemical compounds, okay? The compounds part of chemicals. One is by either calling something simple or complex. So that's a way of separating. That's one way of separating compounds. We separate them into two, simple and complex. That's one way. And one will be simple compounds. Simple compounds will be those that have a relatively small number of atoms. Or here it says about typically 2 or 3 or 4 atoms in them. If you see something that has 2 or 3 or 4 atoms in total, okay, that come from 2 different elements, then we'll call that a simple chemical. So here's an example of what we mean. Look at this. How many elements do we have in here? We have 1 being hydrogen, 2 being oxygen. So we only have 2 types of elements. And how many atoms do we have together in here? We have 3. 2 from hydrogen, 1 from oxygen. And this makes it a simple chemical, right? Let's look at the other one, carbon dioxide. Carbon dioxide, what do we have in here? We have 3 things, 3 atoms, only 3 atoms. So one thing for sure is that simple compounds have a small number of atoms. In here we have 3, in here we have a total of 3, and in here we have a total of 4. So about 2 or 3 or 4 atoms that come from 2 different elements that'll be together. That is what we call a simple chemical compound. Okay, here's another one, ammonia, right? It only has nitrogen and hydrogen that have come together. Nothing complicated, nothing special. We call this a simple chemical compound. And one thing you should know is that these simple chemical compounds will be non-metals together. But we'll talk more about another way of separating. So anyway, simple. It is 4 compounds that have a small number of atoms, about 2 or 3, okay? And they'll be having a straightforward, basic arrangement of atoms, right? And that'll be just your simple chemical compounds. Nothing complicated. It is when you have a few number of atoms and they will have a straightforward, basic arrangement. Now we look at the other type, okay? Because we're separating compounds into simple and complex, right? That is one way of separating. What will be complex? Complex will be those that have a larger number of atoms, not just 2 or 3 or 4, okay, in them, a larger number of atoms, and actually they may have also multiple different elements, more than 2 elements. In here we're seeing just 2, nitrogen and hydrogen, carbon and oxygen, hydrogen and oxygen. So they'll be having, typically involving more than 2 different types of elements with an intricate means complex, complicated, structure. They have an intricate structure. It's not as basic, okay? Because for water, we know that it is just oxygen bonded to the hydrogen and the hydrogen there, stuff like that. But now we have something more complicated, and it's not like nitrogen also where you have it like that, you know, whatever it looks like, nitrogen, then you have 3 hydrogens like that. No, but this is something more complicated. Like, here's a structure. Look at this structure. It's not basic. It's not straightforward. You have different types of bonds. This one is going out of the board. This one going into the board, into the page or whatever. Okay, and we have these single bonds. They're in different planes. It's a 3D structure, quite complicated. Anyway, even if you try to put it, this is very, very complicated thing. So anyway, we'll be saying there's a large number of atoms. We have a larger number of atoms and a more complicated structure. For simple, we had a few atoms and a simple structure, basic arrangement of atoms. But now we have a more complicated structure, and this would be what we call complex chemical compounds. So the complex ones are actually those ones that are very useful to us when we talk about medicine, because they are your drugs. Okay, they're important things. Or in biology, there'll be some very important substance. Okay, for example, vitamin C. Vitamin C is also called absorbic acid, and this one is involved in, it helps in repairing your tissues. And not only that, but it does many other things, like it helps in the nervous responses, because it helps to make a chemical that you use when you're doing your nervous response is when you want to do a quick response, right? Like you put your hand on a hot plate and you want to quickly lift it up, or when you see something you want to quickly run away. So that quick movement, that quick reaction that you do, it helps you to do that. This vitamin C, it's important. But look, it's complicated. Look at what it is. It's a complex thing. So these complex ones are helpful to us, but they don't have a basic arrangement, and they have quite a few things. Look at them. 6 carbons, 8 hydrogens, 6 oxygens. Wow, that's a lot of atoms. Okay, and those are like 3 different types of elements: carbon, hydrogen, oxygen, with huge numbers. Another one is aspirin. Aspirin is a very, very important, it's a very common pain reliever, pain ease, or anti-inflammatory drug. It's an important drug, basically. And when we just say it's an anti-inflammatory drug, we mean that it helps you when you're having inflammation. That is to swell. Okay, it helps to cancel this guy called swelling. Okay, it helps you when you're going through pain and swelling and whatever. So anyway, aspirin, look at it. It's also called acetyl salicylic acid. Okay, so acetyl salicylic acid. This is C9H8O4. Look at how it is. Not so easy, right? That's another way of separating. So here we have this simple versus complex. This is the first idea. This is the first way of separating compounds, not elements. We are only looking. First, we saw what chemicals were generally, and then we saw that we want to look at only the compounds part. And we've seen one way of separating compounds by either calling them simple or complex. Okay, and the idea is just that simple will be just saying that there'll be the ones that are easier to understand. That's what this idea is trying to put across, that some compounds are easier to understand than others. Okay, although this is not something which is fixed, it's not a rigid distinction. We can't say we can easily separate all compounds into either being simple or complex, right? But it is just trying to say, generally speaking, some compounds have a simpler structure than others, and the ones that are simple have a few number of atoms and they have a basic arrangement. But the ones that are complicated have a lot of atoms in one molecule and they are complicated. So anyway, then they can be more complicated, and this may result in differences in their, what is it called, solubility. Okay, it can affect solubility, but it's not something so big that we can use. Anyway, that is number one. It's not so important for you to remember. We are now going into the more important way of separating compounds. Why is it more important, the one we are going into? It is a more important classification because this one which you're about to learn is related to the properties of the compounds. We can be able to know generally some things about reactivity of something, its boiling point, its melting point, its electrical conductivity, like does it conduct electricity or not, its solubility. We can know these things by this separation which we are about to do. This separation helps us. We can actually know if something can conduct electricity or not by knowing if it's molecular or ionic. We can actually know how reactive something is by knowing if it's molecular or ionic. We can know if something dissolves in water by knowing if it's molecular or ionic. We can know if something has a high or low melting point and boiling point by knowing if something is molecular or ionic. So this is very much related to the properties of a substance. And because of that, it is more important than the one which we've just done of simple versus complex. And another thing which I want to tell you is when we say simple versus complex, these terms are subjective. It's not a very common way of separating compounds because, what may be called simple by a biologist is not simple to a medical, a medical doctor, whatever. But the different fields have what they call simple and what they call complex. So it's not the same across the board. And because of that, we don't usually use that description, that way of separating, but we use this one, molecular versus ionic. So molecular and ionic compounds. Let's see what are molecular compounds and what are ionic compounds. You have to master this one, all right? Maybe let me do it in the next video. Goodbye for now.